Hello everyone. We are pleased to present our internship project titled Voice Controlled Robot using MATLAB-Simulink, Raspberry Pi and Atmega 2560. Traditionally, mobile robots are controlled using remote controls or mobile applications. However, these methods require manual interaction and may not always be convenient. Our project aims to provide a more natural way of controlling a robot using simple voice commands. The robot listens to the user's commands, recognizes them, and performs the corresponding movement in real time. Along with voice control, the robot is also equipped with the obstacle avoidance feature, making its operation safer and more reliable. Now, let us look at the hardware and software used to implement this project. Our project consists of the following hardware: Firebird V mobile robot. This is the Raspberry Pi. Atmega 2560 microcontroller that is on the Firebird robot that we are using. The USB microphone for voice input and onboard motor driver circuitry for the Firebird V robot. Also, we have a power supply here which is powering our Raspberry Pi. Now let us understand the working of our Simulink model. The process begins with a USB mic which captures the user's voice commands. This is the audio device reader. The audio signal is then converted into an auditory spectrogram which provides a visual representation of the speech signal. This is the auditory spectrogram. Next, the processed audio is passed through a trained speech recognition model which predicts the spoken command. This block, the predict block, is used for this purpose. The output of the prediction block contains possibilities for all possible commands. These probabilities are then processed by the post-process block that filters out the background noise and uncertain predictions and ensures that only valid voice commands are accepted. This is the post-process box that performs this function. Only a valid voice command is obtained and it is sent to the command decoder window. The command decoder converts the recognized command into a single character command such as F for forward, B for backward, L for left, R for right, and S for stop. This character is transmitted through serial communication from the Raspberry Pi to the Atmega model that we have created. We have also included a word decoder block to display the recognized command on the screen. Right now we are not speaking anything, that's why it is displayed unknown here, but once we start speaking in the mic, it will display the command that we are saying for easy monitoring and debugging. Now let us look at the controller running the Atmega 2560. The Atmega receives the command character from the Raspberry Pi through serial communication. This received character is passed to the motor driver block. Depending on the command received, the motor driver generates the appropriate control signals for the left and right motors. The output includes forward and backward direction signal for both motors, along with the PWM signals. These signals are connected to the motor driver circuitry present on the Firebird robot, which finally drives the motors and moves the robot. We have connected a scope to our predict block that displays on the graph the probabilities of each command that we have. Let us now look into the working of our model. Forward, backward, left, left, right, forward, we have also added an obstacle avoidance feature in our project, wherein once an obstacle is detected, the robot moves backwards. In conclusion, we successfully developed a voice controlled robot capable of recognizing spoken commands and execute them in real time. The project integrates deep learning based speech recognition with embedded systems to provide a reliable method of robot control. The addition of obstacle avoidance further enhances the safety of the system. This internship allowed us to gain practical experience in machine learning, embedded system, MATLAB Simulink, and hardware software integration. Thank you for your time and attention.